Hello class, this is the video for the second part of section 2.1. Now in this video, we'll look at the objectives number 5 and 6, find the domain of a function, and the domain will be writing them mostly in the interval notation, but we'll have also the set theory. So set notation and also in words. And then find the sum, difference, product, and quotient of two functions. And those two functions, each of them will find the what? The domain as well. So let's define what a domain is. Domain of a function f is the largest set of real numbers for which that function is a real number. So if you get an imaginary number or what sometimes we call the complex number, it doesn't include that. Okay, it includes only real numbers. In other words, it is a set of real numbers for which the function is what defined. Okay, so to find a domain of any function from an equation, you always start with the domain as a set of all real numbers. Okay, now if it is not, then you look at the equation that has what? A denominator. In other words, if you have a rational function, all right, then you want to exclude all the values of the real numbers that make the denominator what? 0. Because if you have something like what? 2 over 0, that is undefined. So that's why we do that. Now, the third thing you can also do as a skill or tool is that if the equation involves radicals, then you don't want the number under the radicals to be a negative number. And so it has to exclude all the values which will make it what? Negative value or number under the radical what? Sign. Okay. And then, so we look at examples. First, let's look at the linear equation, which is of the form mx plus what? Plus b. So what's the domain of this? Because this one, it's all real numbers because the value of x is defined, the function is defined for every value of the real number. So the domain of a linear function or equation is what? All real numbers. For example, if you have f of x equal to 5x minus 7, right? If you plug in, if x is equal to 0, then that is f of 0 is what? Is going to be negative 7. If x is equal to, say, 1, then f of what? 1 will be what? 5 minus 7, which is what? Negative 2. Okay, if x is equal to negative, say, 10, then you're going to have minus 50 minus 7, that is negative what? 57. So the domain of this is all real numbers. Okay, the domain is what? All real what? Numbers. Okay, now if you want to write as a set notation or in a set notation form, then it's what? It's x is such that x is what? Is a real number. Okay, then the interval notation, okay, it is all real numbers were from negative infinity to positive what? Infinity. Similarly, if you have a quadratic function or equation, which is of the form, so example is that f of x is called x squared plus that. This is defined for all real numbers. So the domain is what? Also all real numbers. Okay. So this is what? All real numbers. Okay. So if you write in the interval notation, then it's be what? Minus negative infinity to positive what? Infinity. And the third notation will be the same. So it has the same domain as what? The first one. Okay. So here's a rational function or a rational equation. You have a g of x is what? Okay. Now we notice that if you have something like 0, this is what? This is undefined. It's undefined. Okay. So you want to make sure that the denominator is not 0. So the domain will exclude. Okay. So domain excludes all x such that, okay, such that what, x squared minus 25 is equal to what, 0. So we want to solve for that. So you have x squared is equal to 25, and then your x is equal to plus or minus the square root of what, 25, which is plus or minus what, 5. So then your domain is what, all real numbers except these ones. So in words, okay, we can write it in words as what, domain is what, all real numbers except, okay, x is equal to plus or minus what, 5. Or if you have the set notation, the set notation will be what? It will be x is such that x is not equal to what? Plus or minus what? 5. Then the interval notation, okay, in interval notation, it is what? It's from negative infinity, so minus infinity to negative 5 from the left, union minus 5 to positive 5, okay, union, and then 5 to what? Positive infinity. So that is how you write the word interval notation for the same word domain. Okay. So let's go to the next example. This one has radical, is a radical function. Now for a radical function, say if you have like, oh, let's go back. Okay. For radical function, okay, you don't want whatever what's under the radical sign to be what, less than or equal to 0. So it is, you want to be positive. You don't want it to be, sorry, you don't want to be what, just less than 0. You don't want it to be negative. So what you do is that you pick that portion, 5 minus 5t, and then solve the inequality when it is what, greater than or equal to 0. So when you subtract minus 5 from each side, you have minus 5t greater than or equal to minus 5. And then we divide both sides by what? Negative 5 minus 5. But when you divide or multiply inequality by a negative, you switch the sign. So this becomes less or equal to 1. And then you have a t less or equal to 1. So the domain of this function is that. So your domain in this case is what? It's all x, all t, okay, or say they're all real numbers, okay, for which okay, t is less or equal to what? 1. Okay, all real numbers for which t is equal to 1. Then what is the set notation for that? Okay, the set notation, you write it as what? T, because this is a t, such that t is what? Less or equal to 1. Okay, now what is the interval notation? In interval notation for the same thing, the interval notation is what? Everything less or equal to. So you have negative infinity and you have 1, but this time you use what? Brackets because of the inequality. This is inclusive. All right. So that's why I have brackets there. All right. So now this here is another function. Okay. Look at the numerator and the denominator. The numerator is what? Is a radical function or expression. Okay, it's a radical expression. Okay, and then the denominator is linear. Okay, so this is a combination of what? 2 different functions. Now we're going to treat them just as we treat them individually, and then we'll combine. Okay, so for this to to find the domain, we require that the numerator, which is the radical sum, what is under the radical sum must be greater than or equal to what, 0. Now, if that's the case, we have for 2x greater than or equal to -6, and then we divide both sides by 2, and we have x, so we have x is what, greater than or equal to -4, -3. And then, of course, because it's a rational, the denominator must not be what, 0. So we pick that, okay, and set it to 0 and solve. So it will exclude all those. So then we have what, x minus 2 equal to 0, and they have x is equal to what, 2. So if x is equal to 2, it is undefined, and the x must be what, greater than what, that. Now, when we combine these two, okay, combine these two restrictions, the domain of f is what? It is going to be, is what? Your x must be greater than equal to -3, and x cannot be equal to what? Equal to 2. Okay. Then if I write as the interval notation, that is going to be from, okay, it's inclusive. So we have brackets on the -3, okay, and it goes until you get what, 2, but it doesn't include 2. Then union, then 2 to what? Positive for infinity. So this will be the interval notation. The set notation will be in the set of what, x, such that x is what? Greater than or equal to -3, comma, x is not equal to what? Equal to 2. Okay. All right. So now, to find the domain of a function, we express the domain of a function using the interval notation, set notation, or inverse, whichever is most what convenient. But I'm going to use most of the time writing what interval what notation, because in calculus, okay, in Calc 1, all the interval domains, everything is written in interval notations. Calc 1, Calc 2, Calc 3, also, and so forth. So we want to get used to that, how to that form. All right. Now, if x is in the domain of a function, we say that f is what? It is defined, or f of x what exists. Okay. Now, if it is not, then we say it is not defined, and f doesn't exist. Okay. So now let's consider the sum, the difference, the product, and the quotient of our two functions. So you have functions, this is a definition. You have f and then g. The sum is written as well, f plus g of x. And then it's like you are splitting, you are distributing the x over, which is the same as what, f of x plus g of x. Now, what's the domain of that? The domain of f plus g, it consists of all real numbers of, okay, x, that such that the domain contains what is the both of what of the two functions. Okay, the difference, change the plus to minus, you have f of x minus what, g of x, is the same domain, only that this will be what, this is minus. Okay, so the domain of f minus g consists of all real numbers x that are in the domains of what, both what, f and g. Okay, we'll be taking an example and do one example, give it f and g, and then we'll find their domains for the sum, the difference, and then the next one is the product. Okay, that the product function is defined as f times g, okay, in parentheses x, and it's the same as f of x times what, g of x. Now, what's the domain of f times g? Consists of all real numbers x that are in the domain of what? The domains of both what, f and g. Okay. Now, for the case of what, the quotient, okay, which is a rational function, that's how we'll call it. Okay, we do not want the g of x to be what? To be equal to 0. Excuse me. The g of x to be equal to 0, because the if it is 0, then it's undefined. Okay, just like the example that I did with the function for what, a capital what, f of x, that had the radical in the numerator, and then what? It has x minus that. Okay, so what we're going to do is that we want to take example and do each of these. Now, what's the domain of this expression here, of the domain of this or that? The domain consists of all real numbers for which the g of x is not equal to 0. This is from the final expression after you have simplified this guy, okay, that are also in both what, g and f. Okay, so take note of that. What we have here, it is based on what? The final expression. So we'll take an example and I'll show you how. Here is the example. Both of them are rational functions. So as we can see, the domain of f, in this case, if I write here the domain of f, okay, the domain of f, what? It will not include what? If x is equal to -3, okay, if x is equal to -3, it is undefined. So it is all real numbers where x is not equal to what? -3. And then for this one to the domain is what? X is not equal to what? Equal to 4. Because if x is equal to 4, you have 4 minus 4, which is 0. Over here, if it's -3, is what? -3 plus 3, which is 0. You get 2 over 0, which is undefined. Okay, so now we want to find the sum of this. Okay, we want to find the following. We want to determine each of them, the sum, the difference, the product, and then what? The quotient, and then we'll find their domains. And I'll write them in interval notations, most of them. Okay? All right, so here we go. The first example is this. First, let's write down f of x so that f of x is what? 2 over x plus 3. Okay, and then g of x is what? X over x minus 4. Okay, so what is my f plus g of x? This is what? F of x plus g of x. Okay, so that gives me what? 2 over what? X plus 3. Then plus g of x, which is x over what? X minus 4. Okay, okay, I'm going to get more space because I'm going to simplify this. So I'll have a good space there. So plus, and then what? X over x minus 4. All right, so I'll change my color of my pen. Now to have a common denominator, we're going to multiply this by what? The denominator here, which is what? X minus 4 divided by x minus 4. Okay, and then this one we multiply by x plus 3 and then x plus 3. Okay, so then we have, this is what? 2. The numerator is 2 times x minus 4. The denominator is x plus 3 times x minus 4. Then plus x times x plus 3 divided by x plus 3 times x minus 4. Okay, so now we have a common denominator, which is what? X plus 3 times x minus 4. The numerator is what? 2x. If we distribute that, we have what? If we distribute that, we have 2x. Okay, let me erase that part. So if I distribute that, I have what? 2x minus 8, then plus, this is what? X squared plus what? 3x. So that gives us what? X squared plus 3x plus 2x is what? 5x. Then minus what? 8 divided by x plus what? 3. And then x minus 4. So when I have this, the numerator is a quadratic function. So the domain is what? All real numbers. Okay, it is all real numbers for that. Now you can see that the denominator cannot be what? -3, or it cannot be 4. See that? X cannot be this, and S cannot be what? Cannot equal to what? 4. So what's the domain? It's the same as the domain of the f and what? F and g. So in this case, the domain, okay, D, if I denote by D, the domain is what? All real numbers. Okay, all real numbers except x equal to what? -3 or equal to 4. Or you can say that all real numbers is another way to say that. All real numbers and x is not equal to -3 and 4. Now, if I write this as a set notation, it is going to be the set x is such that x is not equal to -3 and 4. Okay. Now, what's the interval notation, which we will be using all the time? The interval notation is all real numbers except this. So from -infinity to -3, okay, it doesn't include that, union -3 to 4 on the real number line, and then from 4 to what? +4 infinity. Okay, so that is the first one, part A. We're going to do the same for the difference. So that's the sum. This is the sum. Okay, now let's go to the difference. Okay, we have written the domain, so let me just. All right, so now let's go to f of x minus g. Okay, this is what f of x minus g of x. Okay, then what's that? It's the same thing. 2 over what? X plus 3, and then plus x over, sorry, I'll change it to -4. This is minus, not plus. Okay. Okay, so minus, that's minus what? 3. To have a common denominator, again, we multiply this by what? X minus 4. And then we divide it by what? X minus 4. And this side to multiply by x plus 3 and divided by x plus what? 3. And then put that in parentheses. So your denominator becomes what? 2 times x minus 4 minus x plus what? 3. Divided by the common denominator, which is x plus 3, x minus 4. So let's simplify the what? The numerator. You have what? 2, multiply it out 2 times 2x, okay? 2x, and then minus 8, then minus x squared, minus 3 what? 3x divided by the same denominator, okay? X minus 4. So now, you've got to simplify that more. So we have what? Negative x squared, which is that, and then my 2x minus 3x is what? It will be minus x, and then -8, then divided by x plus 3, x minus 4. Now we can write this as, because the numerator is what? It's all negative, we can factor -1 out, and then we have what? X squared plus x plus 8 divided by x plus 3, x minus what? Minus 4. Okay, so you can write in this way. What's the domain? Okay, the domain of that consists of all real numbers, okay, as such that they are in the domains of what? F and G. Okay, so in the interval notation, this will be the same thing as what we had, to be negative for infinity to what? -3, because the domain of what? The F, it doesn't include what? -3, and domain of G is what? Doesn't include +4. So the union, -3 to 4, union what? 4 to what? +infinity. So you see that this domain, as we got, is the same as for the what? For the sum, F plus what? Plus G. Now, I will not say always this is the case. I would say most of the time that is the case. Okay. All right. Now let's go to the third part, part C. Okay. Or if you want to write it as a set notation, it is as such that x is not equal to -3 or comma x is not equal to 4, or you can just say that x is not equal to -4, -3, comma 1, comma 4. It's all the same. All right. Now, the product, okay? The product for the same functions, all right? Your f of x again, okay? Your f of x is what? 2 over x plus 3. And then g of x is what? X over x minus 4. So the product is what? 2 over x plus 3 times x over x minus 4. I don't need to find common denominator, I just multiply them across. So that gives me what? 2 times x is x, 2 times x is x, okay, divided by x plus 3 times what? X minus 4. Okay, so then what's the domain of this function? Okay, it consists of all real numbers that are in the domains of both what? G and then G and F. Okay, so it is the same as before. Okay, or in an interval notation, this is what? -infinity to -3 union -3 to 4 union 4 to what? Positive infinity. Okay, so then the next one is tricky. So that's the last one we're going to do. That's the quotient. Okay, f of x divided by what? G of x. Okay, so we're going to write this again. This is what? F of x is what? 2 over x plus 3. Okay, now everything divided by x over x minus 4. Okay, so let's simplify. This will be 2 over x plus 3 times, then you flip that, which is x minus 4 over what? Over x. Okay, so this will give us 2 times x minus 4 divided by x times x plus what? 3. Okay, now what is the domain of f? It was all x, all real, but not x is equal to -3. And then the domain of G is all real numbers, but not x is equal to what? Equal to 4. Now you notice that this one has a condition that the G of x, the G is not equal to what? Is equal to 0. Now if I look at this, the denominator here, if you have x times x plus 3, set it to 0, you have what? X is equal to 0 or x plus 3 equal to 0. Now you notice that, okay, you notice that this part, x minus 3, is coming from the same as the domain of all the f. But the only difference is that or the, I would call the extra, is what? X is equal to what? 0. So it's the domain. Let me see, I think I have written it here. Oh, let me erase this part so they can see. Okay, so the domain of this expression is what? All real numbers. Okay, all real numbers for which the G of s is not equal to 0. Okay, a G of s is not equal to 0 when x is equal to 0. So we exclude what? 0 as well as what? -3 and then 4. So we exclude this. So writing them in the interval notation as a set notation is going to be what? X is such that X is not equal to -3, is not equal to 0, is not equal to what? +4. Or you can just say that this is what X is such that X is not equal to -3, 0, comma, and then 4. So this is the same as that. Now in interval notation, then we write this as from -infinity to -3. It does not include, comma, -3 to what? 0, because 0 comes before what? 4 when you're on the number line moving from left to right. Okay. And then union 0 to what? 4. And then union 4 to what? +infinity. Okay. So that's my what? This is the what? The interval notation. Okay. So that actually brings us to the end of part 2 of section 2.1, and I'll see you Friday. Thank you.